Hello guys, my name is Dylan. My YouTube channel is DRG Bros. And today we are going to be doing some vector operation skills. So, first of all, let's do a review. So, a vector from the previous video, if you haven't seen my previous videos, watch them. From the previous video, we found out that a vector is an ordered set of numbers. So a way we can represent the number is perhaps a, and that is one of the symbols that represents a vector. And then this is important. This vector is important. We're going to be using this throughout the video. So vector A can be represented as 1, 2, 3. Okay? And that's like a matrix form. And then the second way we can represent our fraction is, this is the way we're going to be probably using most for this video, is 1, 2, 3. Okay? And then here's another one that we need to remember. It's B. Vector B. So this one is 3, 2, 1. Or 3, 2, 1. Okay? So these are two important vectors that we're going to use for this problem. Okay? So another way we can write vectors is in kind of like a graph, which is called the 3D in this case, because we have 3 numbers. Which actually, let me explain how 3D works. So, or dimensions work. So a dimension, like, you might be thinking, dimension is basically a way of showing down the numbers. So you might be thinking, okay, zero dimensional does not exist. Zero dimensional cannot be a thing. Zero dimensional is one dot, 1 point. Okay? Now, one dimensional is if we can slide that point around. So basically, it's an infinite or continuous line. Now that's 0D, E, and 1D. Now 2D is when we put a bunch of lines like this, where it's kind of like they're right next to each other. So it's still flat, but it's wider, if you want to put it that way. Now 3D is when we stack these lines. Like if we take this and then we stack it. And then 4D would basically taking that stack and like if this was a stack, like spreading it out, making it wider. Okay? So this is the 3D coordinate system, so. Because it has 3 axes. The x-axis, or x1, x2 or y-axis, and x3 or z-axis. And so how we represent this is, let's represent 1, 2, and 3, or vector A. So, take one step. I'd say that's about right here. Okay? Because there's no really way to be accurate with the steps. But we can say that's one step. So then 3, then we take 2 steps. So 1, 2. So that's about here. Then we take 3 steps up. 1, 2, 3. So we can represent this as an arrow. Okay? Okay. Now let me teach you about scalars, which if you might have heard of them, you might have not. It's okay. So a scalar is basically a single number that stretches or shrinks a vector. So what we can do, so this is 2, and it's about scalars. Okay? So a scalar would be perhaps 3, and then here's our vector. So how we're going to solve this, we can do something like this, and then it's going to be 3, and then we show our vector. So 1, 2, 3. Okay? And then we kind of distribute like that. Okay? So this vector, after adding scalar of 3, would be 3, 6, and 9, because we're multiplying. So that's my final answer. Okay? And then when I say stretches, that's how we stretch our vector. But how do we shrink our vector? Let's say we take 0.5. 0.5. Okay? And then we have b, our vector b. So it's going to be equal to 0.5, 3, 2, 1, and then we distribute like that. So pause the video now if you want to take a guess, but okay. So how you actually do it is actually you don't distribute. I just realized that I made a mistake there, but you actually don't distribute anything. Actually, you do. But all you do is, this is why I chose 0.5, because this one's the easiest one. All it is you take half. So 1 and 0.5, that's 3. 1, 0, and then 0.5. Okay? Simple enough. And that's our final answer, so we always box it. Now let me get a new sheet of paper out. And then this one is linear combinations. Okay? So this is number 3. Linear combinations. So our problem is going to be 3a, or vector A, plus 2 vector B. So it's going to be equal to 3 vector A, or 3, not vector A, it's going to be 1, 2, 3. Plus 2, 3, 2, 1. So then we use our scalars. So it's going to be 3, 6, 9 plus 6 4 2. 6 4 2. And then when we add these two vectors, it's going to be 9, 10, 11. Okay? So now we're going to move on. But first let me show you a new vector. This one's gonna be we're gonna need it for future problems. So this vector is going to be C. Vector C. And C's vector is 1, 0, 2. Okay? Now if you want to practice a little bit doing linear combinations, here's another problem. So you can do 4, okay. So if you want a little bit of practice, you can do that problem. Now, moving on, we're going to do one called the dot product. Okay. So the dot product is pretty simple. But we're going to multiply two vectors. So it's going to be vector A dot vector B. So what that actually is vector 1, 2, 3 dot vector 3, 2, 1. Okay? So now we're going to kind of distribute like here, here, and here. Okay? So it's going to be 2, 1.3 plus 2.2 plus 3.1. And then when we do the multiplication, it's 3 plus 4 plus 3, which is equal to 7 plus 3. So this one is a scalar, and our answer is 10. So now, basically the dot product is going to give us scalars. So this one, vector A dot vector B, gives us a scalar of 10. Okay, as again, if you want to practice a little bit, but I don't know if I'm going to have enough time to do this one. But if you want to practice a bit, you can always do this problem. Okay? Which honestly isn't that hard. It's pretty easy. Dot product is a pretty easy way to get scalars, but there's other ways. Like this next one. This one is called vector norm. Okay? So this is how we determine like how big or small, or how fast, and like how strong is a vector. Like we determine its like strength. So we're gonna draw kind of like double bars, and then vector A, and then double bars. These are not minors. These are not minors. So what we can do is do the squared root of vector A dot vector A. Which is equal to the squared root of vector A, which is 1, 2, 3. Okay. And then that's going to be equal to the squared root of 1.1 plus 2.2 plus 3.3. Okay. And then that's going to be equal to the squared root of 1 plus 4 plus 9, which then is the squared root of 5 plus 9, which then is equal to the squared root of 14. Okay? Now we got 2 more to go. We got 1 more to go, and then we'll do a summary review and then a bonus question. So this last one is number 6, which is cross products. So cross product is A, vector A, cross product, vector B. And so, now I did a video on this, and it will walk you through this exact problem. And so, this one's a little long, take like a little bit of time. So if you want, stop the video and fast forward a little bit to the summary review if you do not want to know the answer. So if you do want to know the answer is -4, 8, -4. Okay. So now, okay. So number 7. Is the summary review. So, the operation and the result. And we can draw this in a T-chart. Okay, so scalar gives you vectors. Okay. Now, what about the linear combination? Did you say vector? Well, if you did, you're correct. So what about dot products? Did you say scalar? Then you are correct. Okay, this next one? What about cross products? Assuming that you've gone and watched the video. The answer is vector. Now, what about the norm? The vector norm. Did you say scalar? Well then, you're correct. Okay. So that's our summary review. 3 of them gave us vectors, while the other 2 gave us scalars. So now, the last thing, the bonus. Okay, so we have our vector here. This is a okay. So you see this problem? Tell me, is this gonna give us a scalar or a vector? Pretty tricky, huh? The answer is scalar. Now, you might be wondering why. Now, let's just say that this is A, and it's a dot, and this is our cross product. Well, let's just say these made us a new vector, perhaps vector D. Or D. 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 Vector D. Now it would be a dot product, which gives us a scalar. Okay? Thank you guys for watching, and I'll see you next time.